I'm going to show the differentiation of the implicit function again if the functions are in the division form. This is the function given and we are going to find out dy by dx, derivative of the y. So let me start dy by dx upon the both side, because the functions on the left side it is written as a quotient rule, so we need to apply the quotient rule here. So we know and right side we need to apply the product rule, left side is the quotient rule. So we know the quotient rule is d by dx of, if it is written there u by v, then according to the rule we need to write here sine y and d by dx of x square minus x square into d by dx of sine y, and on the below we needed to write sine square y because square of the v, and on the right side product rule need to apply, which is x, then dy by dx plus y into d by dx of x. So now let me complete our differentiation part from the top and below. So it is given here sine y into, if we differentiate x square it gives us 2x minus x square into cos y, then we need to write beside it dy by dx because it's the function of y, and on the bottom it is sine square y as a denominator, and on the right side it is x dy by dx plus y because dy by dx of x equals to 1. Now we need to multiply sine square y on the right side, and it gives us uh, uh, 2x sine y, then minus x square cos y on the, from the top we got it, and on the right side it is x sine square y dy by dx because we took part in the cross multiplication, because this we needed to we are going to multiply on the right side, so y sine square y. Now we need to make dy by dx as a subject from here, and rest of the part, so if we give a line here we can write it, rest of the part we can keep it on the left side, say 2x sine y, then other part is minus y sine square y because that one I took on the left side, and on the right side you can write x sine square y dy by dx, then plus x square cos y dy by dx. That is the expression. Now just take dy by dx common and make it subject. Dy by dx you can write it as a, this part we need to write top 2x, we can take sine y common as well, let me take sine y common, 2x minus y sine y, if we take sine y common on from this side, then you can write it sine y, and on the bottom dy by dx, if after taking the common, then the remaining part is x sine square y plus x square cos y, and this is our answer of this question. Hope you understood the way we have done this question. I prepared another question for you which is like this, same type of expression, implicit function. On the left side you need to apply the quotient rule, and the right side normal rule. So let me apply the quotient rule on the left side. From here you can write here sin x first, sin x, then d by dx of cos y minus cos y into d by dx of sin x divided by sin square x, yeah, and on the right side if we differentiate with respect to x, it gives us 6x plus 2 dy by dx. Now again we need to make dy by dx as a subject, so let me finish on the top part differentiation and multiplying on the right side as a sine square x. Then we got from here sin x into cos y. If we differentiate, then we got from there minus sin y, then dy by dx minus cos y. If we differentiate sin x, it gives us cos x, and on the right side it is 6x sine square x plus 2 sine square x dy by dx. So this is our expression. Now our target is to make dy by dx as a subject, so we can keep like this, say this expression, let me take minus sign, then it becomes both are positive, so one minus sign will be there. So minus cos y cos x, this expression, and take it on the left side, minus 6x sine square x. Then on the right side, this is the on the right side, which is 2 sine square x dy by dx, and that expression we can take it on the right side because it's having with the minus sign, then it becomes plus sin x sin y dy by dx. So now we can make dy by dx as a subject, and the expression would be, we can take minus common and we can write it, say cos y, sorry, we can write the expression cos y cos x plus 6x sine square x, because I took the minus common, and from the right side, if we take dy by dx common, then the remaining part is 2 sine square x plus sin x sin y plus sin x sin y. There is nothing we can cut out by taking the common, so this is our answer of dy by dx. Hope you understood this question. I'm keeping the dy by dx on the right side. Same type of expression I prepared for you, another one. This is having with the tanx and cos y, and on the left, like before, quotient rule, and the right we need to apply the product rule. So let me apply. So first one we need to write cos y, then dy by dx of tanx, this is the quotient rule, minus tanx dy by dx of cos y divided by cos square y, and on the right side it is x dy by dx of sin x plus sin x into dy by dx of x. Let me finish our differentiation, which is cos y, and if we differentiate tan x, it gives us 6 square x minus, then the part is tan x, and if we differentiate cos y, it gives us minus sin y. Then we need to keep dy by dx according to the rule of differentiation of the implicit function, and let me take this cos square y on the right side, then it becomes cos square y, and on the bracket you can write x sin x. If we differentiate, it becomes cos x plus sin x, and dy by dx of x is 1, so we do not need to write. Now our target is to make dy by dx as a subject, so it's more easier. I think only the one expression having with the dy by dx, this is the expression, so you can write it, say minus minus positive plus tan x sin y dy by dx. I'm going to write that one first, then keep everything on the right side, which is x cos square y cos x plus cos square y sin x, we can write it, and if we take this y on the right side, it gives us minus cos y sec square x. So now let me make dy by dx as a subject. Then the expression is we need to write the whole thing. X cos square y cos x plus cos square y sin x minus cos y sec square x, and on the bottom it is tan x sin y. It's a huge. So this is our answer of this expression dy by dx.